Hello, we had some questions on the empirical rule, which is about if you have a big list of numbers and you organize them, and if they make a nice standardized graph where the mean is in the middle and it's right here. Here's a graph that is standardized. The mean is in the middle and the stats are evenly distributed on both sides. If you have this information standardized, 68% of the information is within one standard deviation of it. So this whole thing is 68. And then within two standard deviations of it, so going out two of them, you got 95% of the information. And last of all, if you go out three standard deviations, so 1, 2, 3, 99.7% of the data is within that three standard deviations. And so the whole thing is 100%. It splits down to middle to 50% each. So then just taking it out here just to show what each one of these bars mean, 68% out means 34% on both sides. I could make that tidier, I think. Let me see. Okay. And then if you take the 95 minus the 68 and divide that by 2, you get for the next two that they're 13.5%. So 13.5% are in those bars. And then last of all, these other two bars out here, again, 100% going all the way across it. But so if you take, well, it's 99.7% that's in there and subtract the 95% from it for those two bars between them and then divide that by 2 again, and you get 2.35%. And last of all, again, the whole thing's 100, take off 99.7, divide that by 2, and that's the outside of it, and that's 0.15. So 0.15% of the data is outside those standard deviations of 3. All right, so let's look at it with a problem here. It says scores on an IQ test have a bell-shaped curve, a standardized bell-shaped curve. That's what the empirical rule is about. It has a mean of 100, so in the middle of it, it's 100. And it has a standard deviation of 17, which means for each bar that you go out, it's 17. So 100 plus 17, 117, and then plus 17 more gives you 134. And then plus 17 is 151. Going backwards, a standard deviation, so subtracting off 17, you get 83. And then 83 minus 17, you get 66, and then 49. They'd like to know what percentage of people have an IQ score between 49 and 151. Well, that's within 1, 2, 3 standard deviations. And within 3 standard deviations is 99.7% of the data. Then let's clean that up. Then they'd like to know, I erased that number, I'll put it back. Then they'd like to know what percentage of people have an IQ greater than 66. There's 66. Less than 66. Okay, so going that way, but yet greater than 134. So that would be these outside two bars, or so you could add up those outside bars right there to get the number of 5%. If you add 0.15, 2.35, and add it again, it adds to 5. Or what you could do is knowing that the whole thing is 100%, and you're missing those middle two bars that go out 2, and that's 95% of the data. So 100% minus the middle, 95% gives you the outside 5%. And then they'd like to know, how about a score more than 134? So more than 134 would be these last two bars. And those last two bars were 2.35 and 0.15, which add up to 2.5. All right, let's see what else we got here. So the next one says that we have another bell-shaped curve. So a bell-shaped curve, again, is that empirical rule of 68, 95, 99.7. So I like to just draw a line, put a bell-shaped curve on top of it. And then you're going to make 3 lines on both sides. 1, 2, 3. The middle of it was 515. And then each standard deviation was 110. So going to the right, you're going to add 110 over and over again. So 515 plus 110 is 625. And then you get 735 plus 110 is 845. And then going the other way, subtracting 110, you get 405, 295, and 185. First question wants to know what scores are between 185 and 845. Again, the empirical rule is 68, 95, 99.7. So all the way from here to here, between 185 and 845 is within 3 standard deviations, so 99.7% of the information. Then they want to know less than 185 and greater than 845. Those were the 2 little pieces that were on the outside, which hopefully you wrote it down. Those little pieces on the outside were just 0.15. So add those 2 up, and that adds up to 0.3. And then the next one wants to know, what about a score greater than 735? So that would be these 2 bars. So the 0.15 and that bar right there, which was 2.35, which adds up then to 2.5. Okay, the next one is not a bell-shaped curve. It says in 2018, the average price of regular unleaded gasoline, excluding taxes in the United States, was $3.06. Assume that the standard deviation price per gallon is 8 cents per gallon, and use I practiced it before I started. I can't even do it. I looked it up on the internet though, and it pronounces it really well. Anyway, so that Russian mathematician. So we're gonna draw a curve again though. Let me see here. So, but it's not standardized, but it's still, according to the Russian math person, it follows some logic. So in the middle of it, the gas is 306. Yeah, they said $3.06. And we're going out 8 cents for each one. So add 8 to that. 8 cents would be 314, and another 8 cents is 322. And then another 8 cents is 3.3. Going backwards, subtracting 8 cents, 2.98. And then you got $2.90 and $2.82. Okay, so the first one here, letter A, they'd like to know at least what percent of the gasolines had prices within 2 standard deviations. So it's a formula that we're supposed to use. And the formula for it that tells you how much is within 2 standard deviations is 1 minus 1 over k squared, and then times 100%. So within 2 standard deviations, the k is the number of standard deviations. So put a 2 in there. So 1 minus 1 over 2 squared. So 1 minus a fourth, which is 70.75, and then multiply that by 100, and you get 75%. So 75% of the information, according to the Russian mathematician's theorem, is within 2 standard deviations. And then we do the same thing again. What about if it was 1.5? So same formula. So put a 1.5 in there instead and square it, and then multiply by 100, and you get 55.56. And then it says the gasoline prices that are within 1.5 standard deviations. All right, now that takes a little bit more work. Let me erase a little bit so we got some room for it. This is another formula. So using the other formula here, to figure that one out, you want to take the average, which they call mu, minus 1.5 standard deviations are the average plus 1.5 standard deviations. And that gives you how far out it is. Because I put the 1.5 in there because that's what they wanted to know, how much is within 1.5. So I guess that in front of that would be the K value. Sorry about that. So mu minus K times the standard deviation and mu plus 1.5 times the standard deviation. Okay, mu being the average, which is $3.06. And then plus and minus 1.5, because that's what the K is here. They want to know within 1.5 standard deviations K. And our standard deviation was 8 cents. So that needs to be 0.08. And then when you do the math on that, you get those two answers. Then last of all, letter C says, blank is the minimum percentage of gasoline stations that had prices between 282 and 330. Well, you're going to have to probably work it out backwards to get that. Probably if you just do one of them, it's going to work well. I'll do it over here on the other side. So using that formula again, mu minus K times the standard deviation. They said the answer to that equals 2.82. That would be the minus one. The plus one would be the bigger number. So I'm going to use the minus formula. So again, the average was $3.06 minus K. The amount of standard deviation we have 1.5. Oh, wait a minute. No. But were you trying to find that? I think we're trying to find K. Yes, we're trying to find K. I'm so sorry. What is the minimum percentage? So that's the K value. And the standard deviation is 8 cents equals $2.82. So I'm going to clean that up and solve for K. So 2.82 minus 3.06, because you want to move that to the other side. And you get negative 0.24 and divide that then by the 0.08 and you get 3. So 3 out. And it's not the empirical rule, it's the Russian mathematicians rule. So we're going to have to do that formula again. 1 minus 1 over K squared times 100. So, oh heavens, I'm running out of room. I'll do it on the top here. So 1 minus 1 over 3 squared, and then times 100. So 1 minus a ninth gives me 88.88 repeating, or 0.888. It just keeps going. So times 100 moves it over 2 places, and they said to round it to 2 decimal places. So that rounds to 88.89. I kind of feel like I ought to do C again. That was a lot of work. Well, you could watch it again, I guess. But you're going to have to work backwards from this formula because they're telling you the end result, the money. So just pick one of them, the smaller or the bigger one. I picked the smaller one, $2.82. So that's the minus one. Put in the information, mu, the average was 306. K is what we're trying to find, how far out the prices are from the mean. And the standard deviation was 0.08. We solved it, got 3. So it's within 3 standard deviations of it. So then, because it's not the empirical rule, we have to use the Russian mathematicians formula, which was down here, 1 minus 1 over K squared. So we're within 3 standard deviations, and then we get that answer. I think that's all I have on this. Let me scroll down, see if I'm missing something. Nah, that was it. All right, well, good to see you. I hope it helped.